Hey guys, this is Mr. C, and in this video we're going to be solving a bunch of literal equations. So literal equations are equations like formulas that have a lot of variables in them usually. It's generally more than one. So what they're going to do is they're going to give you an equation like d is equal to RT, and you don't need to know really what that equation stands for. A lot of times it'll be either geometry or physics or something like that. All you need to do is make sure that you are solving for the variable, and at the end you have the variable by itself. And so we want the variable of interest, the item of interest, by itself at the end. All right, so they're going to tell you which variable they want you to solve for, and it is going to be t for this one. And so you look at this equation and it says d is equal to r times t, and this is all about opposite operations, the whole thing. You're always going to be doing an opposite operation. So here's your d, here's your r, and here's your t. I want that t by itself, but it's being multiplied by the r. So if you think of multiplication, you need to immediately think of the opposite of that, which is division. And so we need to divide both sides by the r to get rid of it. And when we do that, we get d over r is equal to t, and now t is by itself, and we are done. That's all you have to do. Make sure that variable of interest, t, is by itself. So I think every time I'll box it in just to make sure that we kind of keep our eyes on that so we know which one needs to be by itself at the end. All right, here we have the same exact one, but this time we're solving for r. Well, still, you have r times t. So I need to, this time, divide by t to get the r by itself. So these two t's cancel just like any numbers would. And this time I get d over t is equal to r. So did I solve for r? Yes. In this one, I want to solve for k. So I want that k by itself. Well, it's being divided by x, and the opposite of division is multiplication. So I just need to multiply both sides by x. Now they'll cancel, and x times y is equal to k. Is k by itself? Yes. That one's done. Since I used to teach physics, I have a lot of physics formulas for you in geometry. Taught that. And so you don't need to know what this stands for. V is velocity, s is distance, a is acceleration, t is time. You don't need to know any of that. All you need to do is get s by itself. Well, this one's pretty easy. If I could just subtract the at term from both sides, I will have achieved that. And so v minus at is equal to s. I just move the whole term over. We've done that a lot of times. And is s by itself? Yes. So we are done. Okay, this time, same equation, but this time I want to get a by itself. Well, a is being multiplied by t, so now this is not so easy. I really need to get rid, just like in a two-step equation, of the constant first. And so now I have v minus s is equal to a times t. And I just said times, didn't I? So the opposite of multiplication is division, both sides. And since I want a by itself, I need to get rid of the t that's with it. And now v minus s over t is equal to a. Is a by itself? Yes. Okay, this time we have the same equation again, but this time we need to get t by itself. Okay, so we're still going to move the s over. Still got to get rid of that first. So I have v minus s equals at, kind of like the last one, but I want t by itself this time. Well, it's got a with it, and it's multiplication. So I need to divide by that a to get rid of it. And now I have v minus s over a is equal to t. So how handy this is It's very handy when you have physics problems or problems where you have all of this information except for t, and you need to plug it all into a little formula. It's easier to do it this way a lot of times than it is to just plug it in from the very beginning. This time we have ax plus by is equal to c. That's called a linear equation, and I want to get x by itself. So I need to take this whole by term and move it over. Just move the whole term over. Those are going to cancel, and I got ax is equal to c minus by. Okay, I need to get x by itself as being multiplied by the a. So I'm going to divide by a. And I get x is equal to c minus by over a. These are all really good EOC questions. They love to ask questions about literal equations. And so let's build up some confidence. This time, same equation, but I want to get y by itself. So I'm going to move the ax term over instead. Minus ax. Get rid of it. I got by is equal to c minus ax this time. And if I want to get y by itself, I have to divide both sides by b to get rid of that, the whole thing. B's are gone, and y is equal to c minus ax over b. At this time, it looks like I have an equation for the perimeter of a rectangle, and I need to get L by itself. So I need to get rid of this whole 2w term, just move it to the other side. So I'm going to get P minus 2w equals 2L. Well, I have 2L, I want 1L. And so I'm going to divide by 2 on both sides. Those will cancel, and I get P minus 2w over 2 is equal to L, and I now have L by itself. This time we have the same formula, but I want to get w by itself, so I need to move the other term over. So I take 2L away from both sides, no problem. So now I have P minus 2L is equal to 2w. Again, I want 1w, not 2. So I divide both sides by 2. And I get P minus 2L over 2 is equal to w. And w is now by itself. Here I have a formula. V is equal to LWH. That's for the volume of a prism, rectangular base prism. I need to get h by itself, which we would call the height. You don't need to know that. We just need to get rid of everything but the h. So it's being multiplied by the L and the w. Well, we can go ahead and divide both sides by the L and the w at the same time. There's nothing wrong with that. Both of them will cancel. And now V, the volume over LW, is equal to h. And now h is by itself. This time we have the circumference of a circle, and we need to get r by itself. Well, again, r is being multiplied by 2 pi. Pi is just a real number, so we're going to get rid of it. Divide by, look why I wrote w from the last one, 2 pi. It's supposed to be 2 pi, and then my horrible pi right there. And so c over 2 pi is equal to the radius of the circle. All right, so here we have a formula from physics, and it says to solve for r. So you need to get r by itself. Now I'm going to show you something really cool here. If you want to get r by itself and you have a proportion that looks like this, one thing is equal to a fraction like this, you can take the a and the r and you can switch them out. And so I'm going to make a prediction that my final answer, if I switch these out, is going to be r is equal to v squared over a. Okay, so if I didn't know that, then I would have to multiply both sides by probably r, right? To move it over. Okay, those would cancel. I get a times r is equal to just v squared. And now I have to divide both sides by a to get rid of the a. But look what I get. R is equal to v squared over a. Exactly the same as my prediction. And that's going to be true anytime you have a setup that looks just like this right here, with one thing on one side and a fraction on the other. One fraction on the other. Okay, this time they're asking me to solve for v, and it's v squared actually, so I do need to get rid of the r first. So I'm going to get rid of the r. I can't move the v around because it's in the numerator. So those r's are going to cancel, and I get r times a. Ar is equal to v squared. But now I need to get rid of that square. So how do you get rid of a square? Well, we learned that a square root gets rid of a square quite nicely because they cancel out. So I take the square root of both sides, and now I have the square root of a times r is equal to just v. So when you take the square root of a square, whatever variable's here just kind of gets unlocked and it goes down here without anything. It's just all by itself now. All right, so here we have an equation. This is actually a linear equation that's in slope-intercept form, and they're asking us to solve for x. So we need to get rid of the constant first, that b. So y minus b is equal to m times x. Well, I need x by itself, so I got to get rid of the m on both sides. And so y minus b over m is equal to x, and now x is by itself. So these can get a little more complicated. This is the formula for the volume of a cone. And so if you have this kind of a setup, it's asking you to get h by itself. So all of this stuff has to go. Well, the first thing you want to get rid of is this fraction. And so what I would do is just multiply both sides by 3, the reciprocal. The 1/3 and the 3 will cancel out because reciprocals always cancel and make 1. So I have 3 times v equals pi r squared h. Okay, so I dealt with the fraction. Now I want to get rid of everything but h. So I'm going to divide both sides by everything but h, pi r squared on both sides, pi r squared. So these are going to cancel out the whole thing, and I got 3v over pi r squared is equal to h. It would not surprise me if they put something like that on an end of course test because those are very common. They're kind of complicated, but they are very common. So let's take a look at that one, and then let's solve for a different variable. Let's solve for r this time. So we still need to get rid of the 1/3. So our first step is to still get rid of this 3, to move this 1/3 over. So we're going to get rid of that 1/3. So we still get 3v is equal to pi r squared h. But now we want to get r by itself. It's r squared, but we can't get rid of that until we get rid of the pi and the h. So we got to get rid of the pi and the h. So pi times h, pi times h. So these will cancel. And now I have 3v over pi times h. And what I really should do for my next step is write this little arrow there that means next step. So 3v over pi h is equal to r squared. So now, how do I get an r by itself without the square part? So again, I need to take the square root of both sides. That's the only thing that's going to handle that. And my answer now is 3v over pi times h, square root of the whole thing is equal to r. Okay, this time I have the formula for the volume of a sphere, it looks like, and it's asking me to solve for r here, and it's r cubed. So what I need to do then is I need to get rid of the 4/3. So I'm going to kind of do this a little different. I'm going to multiply both sides by 3 first, and that's going to get rid of just the 3 right there. Now I have 3v is equal to 4 pi r cubed. I could have multiplied by the reciprocal, and I've done that before, but if I do that, I'm going to get a fraction over here that I don't really want to deal with just yet. All right, so I need r by itself. So I need to get rid of the 4 pi first. Get rid of the 4 pi. So it's gone. So now my next step is 3v over 4 pi equals r cubed. So now the question is, what gets rid of a cube? Well, we know a square root gets rid of a square. For a cube, you need what's called the cube root. And so that looks just like a square root, but there's a little 3 right there called the index, and that tells you which root it is. And so a third root will get rid of that. So a cube root, or a third root, and a cube cancel out. And now here's what I've got. 3v over 4 pi, and that's a cube root, equals r by itself. That's a little bit tougher to put in a computer, like at the end of the year if you have a computer test where you have to enter your answer. It can be done, and we'll practice that at the end of the year, but that's pretty much how you need to handle that. This one is another geometry formula, and it's asking us to solve for n. But before we can really do that, we need to get rid of the 180. You could distribute it if you want to. I would really prefer, though, instead of distributing, I'd prefer to divide both sides by 180 to get rid of it. So I'm going to take both sides and divide by 180. Make it look nice. Okay, when I get rid of that 180 like that, it's going to unlock the parentheses. So I have s over 180 equals, it unlocks the parentheses because there's now nothing in front, n minus 2. Now I'm free to just add 2 to both sides. So when I do that, I'm going to get n is equal to s over 180 plus 2 at the end, like that. And now n is done, it's solved for n. I wouldn't be surprised if they gave you some complicated ones like this, where you have some of these advanced physics problems and they give you the whole setup and everything. And you need to solve for g, this guy right here. So the first thing you need to do is move that r squared over. And so if you multiply both sides by r squared, you get f times r squared equals, those cancel, g times m1 times m2. And they give you this to kind of scare you, but all of these are the masses of 2 objects, and this is really just a gravitational force equation from physics. Not that you need to know that, but these little subscripts, that's just what the masses are called, the mass of object 1 and the mass of object 2. So we need to get g by itself. So we need to get rid of that m1, m2, m sub 1, m sub 2, like that. And so once we divide by those 2 guys, they cancel out. And our final answer is going to be force times the radius, the distance between the objects, divided by the 2 masses, is equal to g, which is our gravitational constant. This time they're asking us to solve for r. We're going to make life real easy on ourselves. You see how you have one thing here in a fraction? You can take that f and that r squared and swap them out. You could write r squared is equal to g m1 m2 over f. Remember how I told you that? That's going to happen. That's what's going to happen if you multiply both sides by r squared and then divide by f. So now if you want to get r by itself, we just take the square root of both sides, like that. And our final step is going to be r is equal to g times those 2 masses over f. So they can make them a little bit more complicated. This one, you have s is equal to x plus y over 2 times a. Again, this is a physics formula, and they want you to get y by itself. So we need to get rid of a first. So if we divide both sides by a, we're going to get s over a is equal to, and now the parentheses are unlocked because there's now nothing in front or behind it, x plus y over 2. So now we need to get rid of, not the x yet, but the 2. So we need to multiply both sides by 2. Those 2's are going to cancel, and now I have 2s over a, this will be my next step, is equal to x plus y. To finish this off, all I got to do now to get y by itself is move the x over. So I subtract x on both sides. So if I do that, now I have 2s over a minus x equals y. And I'm done. Kind of complicated, but that's just the nature of it when they get more complicated for your formula. Here we have a proportion, and it's asking you to solve for q. So there's a couple ways you could do this. Let's go do the more natural way. Let's multiply both sides by q and see what happens. So these 2 q's are going to cancel out, and I'm going to get q times m over n is equal to p. Now I need to get rid of the n. So I multiply both sides by n, and my next step is q times m is equal to n times p, or p times n, either way. Now to get q by itself, divide by m, they cancel out, and I now have q is equal to n times p over m. And q is by itself, and that's what I wanted. Same thing here, but now I need to get n by itself. So if I need to get n by itself, here's one thing you can do. if you have a fraction on one side and a fraction on the other, you can take both sides. I don't know if you know this, but you can flip them. And if you flip them, what you're going to get is n over m is equal to q over p. It's really the same equation, but this time all I've got to do now is get rid of the m. So I multiply both sides by m, bring down my n is equal to m times q over p. So the more math you know, the more little tricks like that you can do to kind of help yourself out. And n is definitely by itself. Okay, here we have the formula for the area of a triangle, and they're asking us to solve for b. So really that 1/2 needs to go first. So we're going to multiply both sides by 2, and that needs to become natural. Those are going to cancel. 2a is equal to b times h. And now to get b by itself, I just need to divide both sides by h. And I got 2a over h is equal to the base. And that is now solved for b. This is has the structure of the formula for the area of a trapezoid. And so normally these would be your two bases over here. But on the EOC, what they'll do is they might take the variables, the same exact structure, but just change the names of them. So h is still the height, but the x and y would be the bases. It doesn't matter. We just need to get x by itself. And so again, I'm looking at that 1/2 and I'm thinking I really need to get rid of that 1/2 first because it's bothering me. So we're going to do that by multiplying by 2. So we have 2a is equal to h times x plus y. Now, before we can start taking things out of the parentheses, we need to get rid of the h now. So we're going to divide both sides by h. These are going to cancel. And my next step will be 2a over h is equal to, that unlocks the parentheses, x plus y. And now we can just get rid of what we want. We want h or x by itself, so we have to subtract y on both sides. And so now we have 2a over h minus y equals x. And that minus y is not in the numerator, it's all by itself at the end of this fraction. Just remember that. Okay, so it's very common to get linear equations like this too, and you just have to solve for one of the variables. This time it's y. So we're going to take that 2x term and move it over, minus 2x. Bring down my negative 3y equals 6 minus 2x. And to get y by itself, we'll just divide by negative 3. And we have y is equal to 6 minus 2x over negative 3. So in this video, I'm not going to show you a bunch of different ways to make this look different. Like there's other ways that this can look and it's still the same thing. Like for instance, you could have written y is equal to negative 2x plus 6 over negative 3. You could have multiplied everything in here by negative 1, and you could have gotten y is equal to 2x minus 6 over positive 3. You could take that and split it up into two fractions. Y is equal to 2/3 x minus 2. And now that's an equation we can graph. Lots of different, there's like 1, 2, 3, 4 different answers just right here. I'll be okay if you just write it like this, because for a literal equation, you've solved for the variable, you're done. And if you want to make it look like this, that's fine. But if you look in the back of a textbook sometimes, you may see it written differently, and you need to realize, hey, my answer is the same as these, it's equivalent, it's just that they wrote it different. And that's going to come with experience too. Okay, this one we want to solve for x this time, so we're going to move the 5y term over. And it really doesn't matter where you put it, so 6x is equal to negative 30 minus 5y. And now to get x by itself, we just divide both sides by 6. And that's pretty much it. X is equal to negative 30 minus 5y over 6. Again, I could make that look different if I want to, but for a literal equation, and that's all we're doing, I'm happy with that answer right there. I'm fine with it. Okay, this time we're going to go ahead and we're going to solve for y this time. So we're going to move the 4x term over and bring down our negative 8y equals 32 minus 4x And then we're just going to divide by a -8. Kind of handle it like a two-step equation. Those cancel, and so y is equal to 32 minus 4x over -8. And we're done with that one. Okay, but some more complicated physics formulas. This one's for kinetic energy, but you don't need to know that. We need to solve for v, which would be the velocity of the object, how fast it's moving. It has kinetic energy. So we need to get rid of the 1/2. Let's stick to the plan here. So let's multiply both sides by 2 to get rid of it. So now we have 2e equals mv squared. We're supposed to get v by itself, so we need to get rid of the m first. Cancel, cancel. So we've got 2e over m is equal to v squared. So how do we get rid of a square? Well, we're gonna have to do a square root. So we take the square root of both sides, like that. And we get 2e over m square root equals just plain v. Okay, another physics formula, and of course, they're gonna ask you to solve for the hardest variable in the whole thing, but we gotta get that t squared by itself. We have to move the vt over first. So those are gonna cancel. So s minus vt plus 1/2, or not plus, s minus vt equals, that's my fault. That's right, equals 1/2 at squared. Okay. Okay, so now I need to get rid of that 1/2 because now here's like my river, right? So I'm gonna multiply both sides by 2. And when I say sides, I mean the entire thing. So a couple ways you could do this. You could leave it like this over here. You could just say 2 times s minus vt, like that, equals, now these cancel, at squared. I need to get rid of the a now, sorry, the t squared now, because I want a by itself. Yeah, I was thinking t squared at the beginning, but now I see it's a. So if I want to get a by itself, I just need to divide by the t squared to get rid of it. And so my final answer I'm going to write over here is 2 times s minus vt over t squared is equal to a. A little more complicated, so now we're kind of in the advanced ones. If you have a good handle on some of the other ones, you want to start getting some challenging ones. And this will be a little bit more challenging because you would see this in physics class when you get to physics anyway. Okay, this one, we want to get r by itself. So we need to get rid of that t. So what's going to happen is this t is going to move over and it's going to be multiplied by the v. And so we get capital T, which is the period of motion, times v, or the period, is equal to 2 pi r. And now we just get rid of the 2 pi to get r by itself. Both those cancel. And my final answer would be t times v over 2 pi is equal to r. All right, this one right here, we want to get v by itself, and here it is squared, so we know we're going to have to take a square root at some point. And we're going to take that r, and we're going to move it over there with the f, because that's what's going to happen anyway when you multiply both sides by r. So f times r is equal to mv squared. So before we can take the square root, we need to get rid of the m first. And so now I have f times r over m is equal to v squared. And now since I have the v squared by itself, I can take the square root of both sides like this. A square and a square root cancel. Put my next step arrows. And so I have f times r over m square root is equal to just plain v. Okay, this one, we want to solve for L, that we're way up there. So this is kind of interesting. This 2 pi has to go, so we're going to have to divide both sides by 2 pi. And when you do that, this whole 2 pi is basically going to go underneath the t. So we're going to get t over 2 pi is equal to the square root of L over g. Okay, so now we need to get L out of there. And the only thing that's going to work is taking both sides and squaring them, because that's going to unlock that square root. It's going to get rid of it. So now I have, and let's think about this, t squared, because we've already learned this, t squared over 2 squared is 4, pi squared is equal to L over G now, all by itself. And if I multiply both sides by G, like this, it's going to take that G, and you can either write it on the side or you can put it with the t squared. We usually in physics put it with the t squared. And so here's what we're looking at. T squared times G over 4 pi squared is equal to now, since those canceled, L. And when you get to physics, you're going to have to take a bunch of numbers and plug them into your calculator. That's going to be kind of tough here because you got all this stuff going on. So as a literal equation, it's not that bad. But when you get to physics, all this building up to that, then you're going to have to start plugging numbers into your calculator and figuring out what this is. And that's going to become a little bit tougher. Here's our last example, finally. That was a lot of them. And this is really the formula for converting between Celsius and Fahrenheit temperature. So we want to get F by itself. And so to get F by itself, we first need to get rid of the 5/9. And really the best way to do that is to, for this problem, multiply by the reciprocal this time. So we're going to multiply by 9 over 5 on both sides. And so we're going to get 9 over 5c equals, these will cancel, and I get F take away 32. Now to get F by itself, I add 32 to both sides, and I wind up with 9 over 5c plus 32 equals F. So if I need the formula to convert from Celsius to Fahrenheit or Fahrenheit to Celsius, I would need the original one and this one to be able to plug my numbers in depending on what temperature I had. As a literal equation though, this is it. This is what you want at the end because you have F by itself. So that is it for literal equations on this video. Make sure to like my video and subscribe to my channel if you haven't already. And we'll see you guys later. Bye.